Section 9.6 deals with solving rational equations. And rational equations take two forms. They can be problems like this one, or problems like this one, in which you have an addition or subtraction problem on one side of the equation. And the method for solving this type of problem is multiplying both sides of the equation by the least common denominator. We're not going to create common denominators and do the addition. Instead, we're going to multiply by the least common denominator, because when you multiply both sides of an equation by the least common denominator, it eliminates all the fractions, simplifying the equation and allowing us to solve it. So, if we take a look at our first problem, this is a really easy problem. The only denominator I have is x. Therefore, my least common denominator is x. And if I multiply both sides of this equation by x times 3 over x is 3. Remember, distributive property still applies. We have to multiply what's in the parentheses by this value. X times x is x squared. And 4 times x is 4x. So you see, all of my fractions are gone, and I'm left with this quadratic equation to solve. So I have x squared minus 4x plus 3 is equal to 0, because we always set quadratic equations to be equal to 0 in order to solve them. And now my signs are the same. They're both minuses. So I have x minus, and I want factors of 3 that add up to be 4. That's 3 and 1. And my solutions are going to be 3 and 1. Okay, so that's a very, very basic and simple problem. If you take a look at this problem, I have a denominator of x plus 1, a denominator of 2x, those are both new, the 2 and the x, and then over here I have an x. I don't have to use that one because I've already used x. So my least common denominator is 2x times x plus 1. And I'm going to multiply both sides of the equation by that. Okay, now when I multiply 2x times x plus 1 times this fraction, 3x over x plus 1, the x plus 1s are going to cancel, and I'll end up with 2x times 3x, which is 6x squared. Now remember, I'm multiplying this whole value times each of these fractions because of the distributive property, so this x plus 1 isn't gone, it's simply canceled in this first multiplication. Now when I multiply 2x times 6 over 2x, the 2x's are going to cancel, and I'll get 6 times x plus 1. That's 6x plus 6. And over here, when I multiply, the x's are going to cancel, and I'll get 4 times 2 times x plus 1. That's 8 times x plus 1, or 8x plus 8. When I move everything to the same side, I'm going to get 6x squared minus 2x minus 2. If I factor a 2 out of each of these, I'll have 2 times 3x squared minus x minus 1. I'm going to observe that this is non-factorable, and so I would solve this using the quadratic formula. Okay, so I'm not going to bother going through and re-demonstrating the quadratic formula to show you. You know, you take the opposite of b, the opposite of negative 1 is 1. Plus or minus the square root of negative 1 squared, which is 1. Actually, I guess I am going to do the quadratic formula for you. Minus 4 times a, which is 3, times c, which is negative 1, all over 2 times a, which is 2 times 3. And this ends up being 1 plus or minus root 13 over 6. These are my solutions. Okay, so inherent in solving rational equations, you're going to need to solve quadratic equations. So you'll see throughout this chapter 9 there are a lot of repetition of the things we learned in chapter 5 in terms of factoring and solving quadratic equations. The other form that I might have is a fraction is equal to a fraction. This is the simpler of the two forms, and they're solved by cross multiplying. Now, in a real technical sense, cross-multiplying is multiplying by the least common denominator, but we've got this great shortcut, so let's use it. So I'll have negative 3 times x minus 1 equals 4 times x plus 1. And you'll notice my fractions are gone. So regardless of the form, whether you're solving by cross-multiplying or solving by multiplying both sides of the equation by the least common denominator, the first step in these problems eliminates all the fractions. So that's great for those of you who hate fractions. Negative 3x plus 3 is equal to 4x plus 4. If I add 3x to either side, I'll get 7x. And if I subtract 4 from either side, I'll get negative 1. So x would be equal to negative 1/7. In this problem, I'm going to have 2 times x squared minus 3 is equal to x plus 2 times x minus 3. So I'll get 2x squared minus 6 is equal to x squared. I'll have minus 3x plus 2x, that's minus x. And 2 times minus 3 is minus 6. So if I simplify this, I subtract x squared, I'll get x squared. If I add x, I'll have x. And when I add 6 to either side, I simply get 0. If I factor this side, this is x times x plus 1. And my solutions are x is equal to 0 and negative 1. Okay, a couple more examples, one of each type. This is a fraction equals a fraction, so I'm going to cross multiply. I'll have 3x minus 3 is equal to 6x plus 12. If I subtract 3x, I have 3x. If I subtract 12, negative 15. So x is equal to negative 5. In this case, I want to multiply both sides by the least common denominator, so I'm going to factor this denominator. Difference of two squares. If I take that denominator, this is already in that. X plus 1 I've already used, so I don't have to use that. This has a denominator of 1, so that doesn't have anything to do with it. So I'm going to multiply both sides of the equation by this. X plus 1 times x minus 1 times 3x over x plus 1 is equal to 12 over x squared minus 1 plus 2 times x plus 1 times x minus 1, which of course equals x squared minus 1, so we're going to remember that as we go through. When I multiply here, the x plus 1's cancel and I get 3x times x minus 1, so that's 3x squared minus 3x. Over here, these will cancel with that, and I simply get 12. Plus 2 times x squared minus 1 is 2x squared minus 2, right? Because this is equal to x squared minus 1, same thing. If I subtract 2x squared, I get x squared. I have the minus 3x. I have 12 minus 2 is 10, and if I subtract 10 from either side, minus 10 equals 0. I'd want factors of 10 with a difference of 3. It's going to be x minus 5 times x plus 2. So x is equal to 5 and negative 2. Okay. Relatively straightforward. Two different things you need to learn how to do. Again, this side I would multiply by the least common denominator. This item I would cross multiply. The least common denominator in this case is x squared minus 1 again, just like the previous problem, because if I use these, I've already used that one once, I've already used that one once. If I multiply both sides of the equation by x times x minus 1, that of course is equal to x squared minus 1. This cancels with that, I just get 2. When I multiply times this fraction, the x plus 1's cancel and I get 2 times x minus 1 is 2x minus 2. When I multiply times this fraction, the x minus 1's cancel, and I get x times x plus 1. That's x squared plus x. And when I simplify, I'll have an x squared. I'll have 2x plus x is 3x. I have a minus 2, but I'm going to also subtract another 2, so that's minus 4 equals 0. Factors of 4 with a difference of 3. So it's going to be x plus 4 times x minus 1 equals 0. So x is equal to 1 and negative 4. In this case, I'm going to cross multiply, and in fairness, with a pretty large item like this, it also sort of makes sense to factor a little bit. I have x squared minus 3x times x minus 4 is equal to 6x. And you can see there's an x that's a factor here. This is x times x minus 3 times x minus 4. And I can divide both sides by x. That's going to be a lot simpler than creating a cubic equation. If I multiply this all out and then combine like terms, I'm going to have a cubic equation. And that will allow me to simplify now, making my life quite a bit better. So this becomes x squared minus 7x plus 12 is equal to 6. If I subtract 6, x squared minus 7x plus 6 is equal to 0. And I want factors of 6 that add up to be 7. So that's going to be x minus 6 times x minus 1. So x is equal to 6 and 1. Okay, so in dealing with rational equations, there are two methods to solve. One is cross-multiplying, and the other is multiplying both sides of the equation by the least common denominator. You can tell which to do by looking at the equation. If you have an addition or subtraction problem on one side of the equation, you should multiply both sides by the least common denominator. If you just have a fraction is equal to a fraction, cross-multiply.